Hello and welcome to this episode of Microchips, and today on the bench we have this vintage Stalker IX SSB CB radio that's come in for a quick service. Now, where this radio doesn't look anything special, I believe there is some form of PLL wizardry going on inside this radio that's probably been in there for quite a long time. So we're going to take it apart and we're going to see what this modification is all about and see whether we can unravel the mystery of it. So let's get started. So let's power it up, see what happens. So volume control's a bit scratchy, so some switch cleaner needed there. So we're on FM. Now these switches have been altered, as we're going to see. So high and ANL down, we have low band. PACB is now plus 10 kc. So NB up, we have mid band. High and NB off, we have super high. And both switches up, we have high band. So 4 bands on this, plus 10 kc as well, very nice. And the clarifier is also working as a shift. So excellent, very nice. So what sort of wizardry is going on inside this to enable this to happen? Well, there's only one way we're going to find that out. Let's take it apart. So we're just taking the mic plug out. Notice it's got a 5-pin plug on it. And the microphone has also got a mic gain on the side of it. Very interesting. So we'll lift the lid off and we are immediately greeted with something up here. Now bear in mind this radio should have a MB8719 in it, and somebody's replaced that and put this in but scratched the numbers out. But I think we all know what this is going to be. This is going to be a 145106 PLL chip. So I'm just looking around for any other change components. We have a wire going to this capacitor. I think that's C79. One of the resistors is lifted, which looks like it's R114. And we have a 1K going down to a capacitor that then links to a link, which I think is L19. We'll have a look on the schematic anyway in a moment. So lifting the underside, and as I thought, there's our diodes. So no EEPROM in this, not needed, not with all those binary adders chips in there. So it's using the binary adders and a 145106 to get those extra bands. Must have taken somebody a while to work this out. And there's nothing else really been altered inside there. A couple of cut traces, one of them goes to that capacitor. So I'm not sure what that's about. But let's have a look, see if we can't decipher what the PLL is. So pin 1 is actually the supply, but on the 8719 it's actually pin 9, so that kind of looks about right now. So we've got a link from pin 9 going to pin 1. Pin 2 is F in, so that's coming from that capacitor. And then we've got 3 and 4, which is oscillator. So that's coming from right near the crystal. 5 divided by 2 out, we don't need that. 6, we've got FS. At 7 we've got the phase detect out, which is going off to that 10k resistor, which we'll look at in a moment. 8 is lock detect, and 9 is one of the binaries. So let's have a look at this, and this is how it looks. So apart from the pins being different and the actual phase detect running the wrong way, everything is as you would expect from a PLL chip. So I think we can comfortably say that this PLL that's in there is the 145106. Going off these, as you can see there, got reference in, reference out. So all they've done is they've just moved jump links over, wire links over, to make it to connect the correct pins up. So that's fine. If it works, it works. Not as neat as a mod board, but hey, it works. So let's have a look at R114. So there's R114 there, the 10k. And we follow it along and it drifts off to the 2 vari caps. So yeah, that's as normal. So we follow it down, we go across, and we come down, and there's our filtering network with the 2 resistors that we would normally remove when fitting another PLL unit in. But yeah, all they've done is they've lifted R114 and injecting the PD voltage in there. Excellent. So let's have a look at the PD voltage whilst we're at it. And to be expected, so you can kind of work out which band it is from the PD voltage. So it is going up kind of incrementally, which you would expect. And we change the bands, the voltage changes. So yeah, absolutely fine, no problem with that at all. Very nice mod. I'll do a little bit of maintenance on it. So, bit of switch cleaner into the volume, work that in. That should get rid of that scratchy volume control. I want to put switch cleaner in the rest of the controls as well. Let's have a look at reception. So we've got my signal generator, we've got our synad meter, and it's normal. No need to go on about microvolts or any of that rubbish. So around about minus 110 dB, it's fine. This is what we would expect. And we'll just have a listen to it in real world. So yeah, that's fine. Nothing to worry about there. So yeah, that's completely normal. So there's my setup, and you can see just as we start getting above 110, minus 110 dB, the noise level starts to increase, but we get around 108, 109, and it's well within. Yeah, that's absolutely fine. That's sensitive enough. So I noticed that the mode select was a bit noisy. So this one's quite easy to take apart whilst it's still in situ. So I've just removed the selection wafer. Just going to drown it in a bit of switch cleaner. We'll close it back up again and we'll work it in. Yeah, shut it down and we'll work it in. That should make that mode select not as noisy as it was. Yeah, absolutely fine. Working quite nice. So I've done a transmitter check. Everything seems to be working normally with the transmitter. Receiver's fine. it's on frequency. Well, it doesn't really matter about that because of the clarifier anyway. You can move it to whatever frequency you want. But yeah, an interesting modification from this vintage radio. So I'm happy with it. It can go back to the customer. Anyway, thanks for watching. Don't forget to like, subscribe, buy me a coffee, join Patreon, join the Facebook group. Thanks for watching, and we'll see you in the next episode.